All right, welcome to Unit 7, Similarity. This is Day 2, Similar Triangles. We're going to look today at how can you prove triangles are similar. Although the similarity proofs aren't coming for another couple days, we're really going to be kind of saving those for a little bit. Today we're just going to be using similar triangles to solve problems. First way that you can actually prove that triangles are similar is by the angle-angle similarity postulate. And that states that if two pairs of corresponding angles are congruent between two triangles, then the triangles themselves are similar. We have an example written out right here. This used to be called angle-angle-angle similarity, but really by the time you know two pairs of angles are congruent, the third pair of angles is already going to be congruent by third angles theorem, so you really only need the two. This is our first way to prove that triangles are similar, and we're going to go ahead and move right into our first example. This is to determine whether the triangles are similar. If so, write a similarity statement and explain your reasoning. Before you pass judgment on a problem, you actually want to calculate the missing angles really quick. So if I actually take 42 and 58 off of 180, I get 80 degrees for angle A. Let me get my drawing tool here. And if I go over here, that actually shows me enough right now. I do have two pairs of angles matching. That angle B corresponds to angle D. Angle A corresponds to angle E. So I'm going to go ahead and say that triangle ABC is similar to triangle EDF, making sure that A corresponds to E and B to D. With a ratio, we don't know the ratio, but this is by the angle-angle postulate. And we'll write that abbreviated as angle-angle similarity. So we'll use a little tilde. So whenever we're doing like side-angle-side for congruency, we never threw this in at the tail end. Whenever we do similarity justifications, we'll put this little tilde here to show the similarity, the angle-angle similarity postulate. Okay, looking at another example, much less information given to us, but these triangles are able to be shown similar, and that would be by angle-angle yet again. Now the angles would be, for instance, angle Q is congruent to angle N by alternate interior angles. Angle M is congruent to angle P, same reasoning. You could have also used the vertical angles in here, that QXP is congruent to angle MXN. But this is enough as I have it. And so that triangle QPX is similar to triangle, I'd have to call the other one NMX to make sure the corresponding parts line up, by, this would be yet again angle-angle similarity. Sometimes you're not given enough information to make the conclusion. Sometimes you can be given other information that is helpful in making this conclusion of similarity. There's another two ways to show triangles are similar. And here are those other two ways. You have side-side-side similarity. And if you are talking about similarity, throw in that little tilde at the end like I was saying, because this is side-side-side similarity. What it does is it looks at the ratios, and if all the corresponding sides have the same ratio, then the triangles are similar, because the sides were proportional. The other one is side-angle-side similarity, and if two pairs of sides are proportional and the angle between them is congruent, then the triangles are similar. So this harkens back a lot to the congruency statements that we had before in the last unit, but these are the only three that you've got for similarity. There are none beyond these. Alright, so on a problem like the example 2 here, it can be kind of troubling to know what matches to what, but the first thing I would do is go ahead and mark off the congruent angles. So if I list out my ways, angle-angle similarity, side-angle-side similarity, and side-side-side similarity, I'm going to go ahead and say it's not going to be side-side-side similarity if they are similar. Let's go ahead and move to the sides. I know it's also not going to be angle-angle because I only know information about one of the pairs of angles. I know nothing about A, B, D, or E. Now, moving right along, let's compare some sides. I know that 9 would need to maybe correspond to 6, but since I've already got that angle in there, I'm actually going to work with the 4, 5, 6 and 7.5. 6 will actually match to 4. Now, how did I know that? Maybe I didn't at the beginning. Let's say I thought that maybe 6 matches to 5, and I try that 6 to 5, and I compare that to 7.5 to 4, which these proportions don't equal one another. Now, what I'll do is get rid of that and say, well, maybe I picked the wrong pair. Maybe the 6 should actually match the 4, correspond to it, and the 7.5 should match the 5. Both of those reduce to a factor of 3/2. So they are similar. I have AC over CD equaling BC over EC. And I had, don't forget, angle ACB congruent to angle DCE. And that would actually be enough to now say that triangle ACB is similar to triangle DCE by side angle side similarity is what I use. Maybe you actually went and compared the 9 to 6, which is also 3/2. If you did it that route, you could have used side similarity. I'm also going to make a statement about the ratio. With a ratio of, since I listed the bigger one first, I'm going to write that ratio as 3 to 2. And there I go. There's my the extent of my explanation and everything. Really quick, going to address this kind of figure. We're going to take a look at the fact that angle M is congruent to itself. So I'm going to make a quick statement about that. So I'm not really doing proofs here. But I am kind of introducing you to how a proof would look with these things. That was by reflexive property. Now I've got the two triangles, and now let's make our comparisons. That 12 maybe matches to, a lot of people want to say 18. MS is actually 30, so that's what I'm going to use, 12 to 30. And I'm going to see if that equals the 10 to 25. And I'm going to put a little question mark above my equal sign. I really don't know if they equal each other yet. I'm going to reduce both of these down as much as I can. 12 over 30 reduces to 6/15. Actually, that reduces further. So it actually reduces to 2/5. 10 over 25 also reduces to 2/5. So it actually does work out that these are equal. Since that's the case, I'm going to kind of write that out really quick. That MP over MS equaled MN over MR. So now I'm actually ready for my statement that triangle MNP is similar to triangle MRS with a ratio of, since I listed the smaller one first, I need to put it as 2 to 5, not 5 to 2. And I'm going to say that this is by the side angle side postulate. Yeah, again, side angle side similarity. And as I said on the last one, you could have also used side. This wouldn't work here since I did not know how long NP and RS are, but I would be able to make the conclusion that NP over RS equals 2 over 5. Also, I can make the conclusion that this angle and angle R are congruent, and angle MPN and angle S are also congruent. Alright, time to finally throw some algebra in there. These two triangles would be similar by angle. So I'm going to write that out really quick. That triangle QTU is similar to triangle Q, and since I went to U next, U corresponds to S by alternate interior angle, so SR. To help me with this problem, I'm actually going to say that QT divided by, and I'm going to refer to my statement, QT matches QS. I made a boo-boo in making this description. I'm sorry about that, folks. The first one, since it was QTU, the second one should have been QRS, my mistake. All right, so then that would mean QT over QR. Now, what I'm going to do is actually move right along and say that equals, I see the 10 and the 4 here, I'm going to make use of those, that UT in the first one will correspond to the RS in the second one. So now I'm going to insert all the expressions in numbers. That QT was 2x plus 10. Divide that by x plus 3 for QR. And set that equal to 10 over 4. So you got to be really careful about making a statement and actually using it correctly. As you saw, I made a mistake because I got a little ahead of myself there. I'm going to cross multiply now. The 10 will multiply the x plus 3. The 4 will multiply the 2x plus 10. And go ahead and get that multiplication done. So 10x plus 30 equals 8x plus 40. Subtracting 8x from both sides, I get 2x plus 30 equals 40. Subtract the 30, 2x equals 10. Divide by 2, x equals 5. It didn't say to actually find x. It wanted to know how long RQ and QT was. So I'm going to plug that back into each expression. That RQ would now be equal to x plus 3, so 5 plus 3 is 8. That QT is equal to 2 times 5 plus 10, so that's equal 20. And that wraps up the problem. So going to do the same process yet again, and it's actually kind of the same situation. This was more of a kind of you try it kind of problem, so if you want to hit the pause button and give it a shot really quick, and then I'll show the solution. Alright, now you can see my setup right here. The x plus 2 will match 3x plus 8, and that will equal 11 over 38.5. Then set this up, distribute it, solve it out, x equals 2, plug that back into 3 times 2 plus 8, and I get a final answer of 14. Hopefully you had no issues there. If you did, you got questions, let me know what you got. Alright, this is the last problem, and this is actually a really important one to talk about. So often I get students get frustrated with problems like this where there's measurements given in different units. And really it's kind of unique to the standard system of measurement where we have feet, inches, yards, and that kind of thing, where if we measure how tall something is, we'll measure it as 5 foot 6 inches, 5 foot 8 inches. That creates a huge problem when you start setting up proportions, and everything actually needs to be in the same unit. So as I do this problem, first thing I'm going to do is actually kind of just go through and change this to 5.5 feet. And change this to 53.5 feet. And change this to 1.5 feet. Okay? And that will actually make doing the problem a whole lot easier if you make that adjustment at the beginning. So if you see something like 5 foot 9 inches, you'd want to make that 5.75 feet. Or you can kick it into inches. For instance, 5.5 feet would be 66 inches. Alright, so you could use 66 inches here, get an answer in inches, and then convert it back to the feet at the end. Alright, as it is, let's go ahead and get going. These triangles are similar, and it's actually because this angle over here on the far left is congruent to itself by reflexive property. I have a right angle right here when I'm measuring altitude. I have a right angle right here when I'm measuring the height of the lighthouse. So since both those are right angles and this initial angle was reflexive property, it's by angle that these triangles are similar. Now I'm going to go ahead and set up a proportion to describe the situation. That x will match the 5.5. And what I'll set that equal to is I'll use the larger measurement, the 53.5, over the 1.5. And I didn't really have to worry about like adding anything to this since it was the whole measure here, like on the problem from before in this lesson that we had to worry about that. I'm going to multiply both sides by 5.5 and get my answer. And just going to use a calculator here. So x is equal to, let's type that in, 53.5 divided by 1.5 and multiply it by 5.5. Alright, I get a pretty intense decimal there, which is 1.96.16 repeating. Since I got that, I'm actually going to convert it into feet and inches. So what I'm going to do now is convert it to a fraction, and I know you can't see what I was doing there. And I got 1,177 over 6 feet. This would be fine as an answer for me. I would give you a check mark, no problem. However, if you want to know what that is as far as feet and inches go, that is 196 feet. And you can get your calculator to switch it into a mixed number. But anyways, 196 feet. 6 goes into 1,177, 196 times. And there is a remainder, okay? And that remainder is 1. So 1/6 as a mixed number. Now that actually helps me out a lot because I do know what a sixth of a foot is. 1/6 of a foot is 2 inches. So 196 feet, 2 inches would be my answer. I like any of these three answers, honestly. I don't really have a preference, but you need to be able to comprehend all three of them for the case of like a multiple choice test or something like that. That wraps up day 2, similar triangles. We got 2 more days of lessons. We got a quiz on the 5th day, and that will actually wrap up this unit. Pretty short unit.